lose a lot of that heavy weight.
Yeah.
First up, they're going to learn how to lighten their heavyweight building material.
This is a standard concrete mix. It's 1 part cement, 2 parts sand, and 3 parts gravel. The gravel and sand that go in this is what is known as the aggregate. The gravel in this particular mix is about standard, and it's about maximum 3/8 of an inch in diameter.
In addition to the standard mixture, Jamie makes up 3 more with various lightweight aggregates. Beanbag foam beads, pumice, and lastly, a material made up of tiny glass beads called micro balloons. Now they just have to let it set. While it does, Adam and Jamie head to Moffett Field NASA Ames Research Center for a crash course in aerodynamics. Glider guru Dr. Steve Smith has some good news.
I'll bet you can make a concrete glider to fly. The whole question is weight. So if you build a concrete glider with some reinforcing structure inside and a lot of filler so that the concrete plus all the other stuff is still pretty light, then of course the speed required to fly it and make enough lift to support its weight will come down, and you may get down slow into the typical range that modern sailplanes fly.
We've been, in our research, we've turned up the glide ratio. What is that?
Well, the glide ratio is the slope that you travel along as you glide. So a typical glide ratio for a modern sailplane might be, let's say, 40 or 60 to 1. And what that would mean is that you would glide 40 miles horizontal for every mile that you would drop, or say 5,000 or 6,000 feet. And so that ratio is the slope that you would make.
Now, there is definitely a lot of food for thought that we got from Dr. Smith here. I thought this was totally ridiculous, and I thought maybe we'd get something that would fall less hard. But, I mean, the information we got here says that we ought to be able to make something that's actually fairly respectable as aerodynamic and made out of concrete.
Back at the shop, the concrete is ready for the weigh-in. To no one's surprise, the standard concrete with the rocks in it is heavier than the alternative aggregates.
Based on this first test, there's some pretty impressive variances in the weight. Everything from foam beads at 68 pounds up to concrete at 115. It looks like we'll be able to come up with a mixture that might be light enough. The question is, can it stand up to the type of pressures we're going to put on it? We're going to have to do some strength testing.
In other words, they need to bulk up their lightweight concrete with some muscle.
The single biggest problem with the concrete glider is the concrete. Concrete has compressive strength, but no tensile strength, which means you can put a block of it down on the ground. You can sit hundreds of thousands of pounds in that block and it won't crush. But you can make a thin sheet of it, push it through